This example is related to conditional probability. Suppose there are 10 tiles in a box. The tiles are either red or blue. The shapes of the tile are either square or triangle. A summary is given. So there are 2 blues that are also triangle shaped. There are 4 blues that are square shaped. So the total number of blues is 6. There are 3 reds that are triangle shaped and 7 reds. Sorry, I did that wrong. There's 1 red that's triangle shaped, and there's 3 reds that are square shaped. So in total, there are 4 reds. There are a total of 3 triangles and 7 squares. The grand total of all in the box is 10. Suppose that 1 tile is drawn randomly from the box. A. What is the probability how do you spell that? Probability. I should just say chances. What is the probability that the tile drawn is blue? So what's the chance that I get a blue? The probability of blue is going to equal the number of blue divided by the number in the sample space, which I'll call S. So the number of blue in total is 6. See over here. There's six blues. Some are triangles, some are squares, but there's 6 blues. And then in total, there's 10. So that makes 60%. You could reduce the fraction to 3/5 if you want. B. What are the chances of drawing a triangle. So the probability of getting a triangle, maybe I should just put a shaped triangle. The probability of triangle is what? Well, it's the number of triangles divided by the number in the sample space S. So out of the triangles, we see that some are blue and some are red, but in total there's 3 triangles. And there's a total of 10 tiles. So that makes 3 out of 10, which is 30%. Okay, so 60% chance you're going to get a blue, 60% or 30% chance you get a triangle. What is the chance of drawing a tile that is blue and at the same time triangle shaped? So the probability of blue and triangle is equal to the number of blue and triangle, which you could put intersection, that's intersection, triangle, divided by how many you have in total. So going all the way up here again, blue and triangle, there's only 2 of those. And then there's a total of 10 things that can happen, so that makes 20% chance that you'll get a blue triangle. Yeah, I mean, I wrote this in a weird way. Why don't I just say, what's the chance of drawing a blue triangle? D. What is the probability of drawing a tile that is blue or a triangle? So this means that you could get a blue that's a square, you could get that, or you can get a blue that's a triangle. But you could also get a triangle that's red or a triangle that's blue. But anyway, so let's look at this. This is probability blue, union for or, triangle. And the way you find that is you use the sum rule. This is the probability of blue plus the probability of triangle minus the probability of a blue triangle. So this will be 6/10 plus 3/10 minus 2/10. 6 plus 3 is 9, minus 2 is 7/10. So we get 70%. Another way you could do it is just take 100% and subtract the chances of getting a red square. I'll give you the same thing. Now we're going to move on to the idea of conditional probability. That was sort of the point of all of this anyway. So that was, we did A, B, C, D. Look at this chart again. Okay. But by the way, maybe I'll just draw this over here, just to sort of make this even better. Remember, the intersection is that overlap here. So if you have blue and you have triangle, the intersection is those things that are blue and triangle, while the union is drawn with a Venn diagram as shown So you have blue, triangle, and the union is this. That's or. It's things as shown. So let's go on to E. If a blue tile is drawn, what is the probability that it is a triangle? So I think the best thing to do would be to go back to our chart here and see what's going on. So if I just focus on all the blue, so you take this out and you're saying it's blue. So here's S. And you have blue, and you have triangle. Now, what we're doing is we're only looking at that part that's blue. So it's as if that's our new sample space. And out of that blue, there are two triangles. We call this a conditional probability. So it's the probability of getting a triangle given that the first one draw is a blue. And what you do is you count the number of the triangles that are blue and divide it by the number of blues. So how many are there that are blue triangles? There's 2. How many blues are there that are 6? So it's what we're doing is we're ignoring the rest of the table. Out of 6 blues, there's 2 triangles. So it's 2 out of 6 is 1/3. That's a conditional probability. All right, let's try the next problem, which is if a triangle is drawn, what are the chances that it is blue? So we're trying to find the probability that we get a blue given that it's a triangle. So that again is a conditional probability. We can go back to our chart, see what's going on. So this time, we're just going to look at the triangles. In total, there are 3 triangles. So that's like our new sample space. So it's the number of triangles that we're going to divide by. In the numerator, we're going to write the number of blue and triangle. So that makes 2 out of 3, which, if we're putting these in percents, that's about 66.7%. By the way, the one above here is 33.3% about. So our formula for conditional probability is the probability that B occurs given that A has already occurred is the number of elements in A and B divided by the number of elements in A. Now, what we can do is divide the numerator and denominator by the number of elements in S. And what does that give? That gives the probability of A intersection B divided by the probability of A. So we have two different formulas that we can use for conditional probabilities. If we're counting, which by the way we don't always do, if we're counting, we can use this one right here. We can, if we know that say the first tile is, or the first tile drawn is whatever belongs to A, then what's the probability belongs to B? We find those things that are A and B and divide by the number in A. But you can also look in terms of probabilities. You can find the probability of B given A is probably A and B divided by probability of A. So we have those two different formulas that we can use to find conditional probabilities.